This is a special case of a path model. It's called a mediation model. I use it here only as an example for how we can set up the diagram and notation. So here we have an X, which is an exogenous predictor. M is sort of this middle type variable. It's an outcome to X, and it's a predictor to Y, and it's in between X and Y. And then finally, we have Y, which is our overall outcome. So 3 different regression paths listed here that connect these 3 variables together. Next, we can take this model, change it a little bit, and then map literal notation onto it. And this will give us the foundation for path modeling. So here we have our same 3 variables, but I've renamed them. I named them X1, and then we have Y1 and Y2. We can see that the structure of this model is the same though. The X's, we just have one of them, is an exogenous variable. We have 2 Y's, these are endogenous variables, and they're linked together through regression paths. The paths that link the exogenous variable inward to the endogenous, those are called gammas, and I have 2 of those. The single path that links the 2 endogenous variables together, that's called a beta. We have disturbance terms linked to the endogenous variables, and we have a psi, or a phi, which is linked to the exogenous predictor, and that is a variance. Here is the notation guide. I put the figure up here just so we can remember what it is, but this is the literal notation mapped onto this picture. So our disturbances are called zetas, right? If we correlate things, we can have omega, which would be a covariance matrix or correlation matrix for the disturbances. We have 2 types of regression paths. So the same thing, but we denote them different just to say, is it exo to endogenous or 2 endogenous variables together? And we call those gamma and beta. And then next we have phi, which is a variance here for X. If our model was bigger, like actually we see here, then that could end up being an entire covariance matrix. But here it's just going to be a variance because of how our model is structured. So these are the core elements of the path model. And here are the priors that we can use. We can use an inverse Wishart prior for any matrix. And so we see one of those here linked to zeta. We see one here, which is linked to phi. And then we can use a normal prior for the regression paths. So it's really pretty simple, just a couple of different forms of priors. If we have an individual variance, then we would specify inverse gamma. If it's an entire covariance matrix, inverse Wishart, and then otherwise just normal distributions for those paths. So next we can look at the code. The path analysis code is really simple. It basically just creates structured regressions among observed variables. And so for this example, I just pulled an example from the Mplus website. We have 6 variables in the model. There are 3 Y's and 3 X's. The entire Bayesian model can be simply estimated here just by writing out estimator equals Bayes. We don't have to go through and override any default settings, and it's such a simple model that we wouldn't have to change priors probably either. The model is written out like this. So we have Y1 and Y2 regressed onto our X's. So we know that the X's are predictors, exogenous predictors in the model, and Y's are going to be internal endogenous variables. And then Y3 is the overall outcome, and it's regressed onto these 3 variables here. So the on statements tell us that these are regression paths, just like how we saw that the by statement was for a loading, and then with statement is for a covariance. Now for the output, it's equally simple to understand. This part just shows the information about the types of variables that we include in the model. So we have 3 independent variables. Those are the predictors that are exogenous. And then 3 dependent variables. Those are going to be the endogenous variables, with Y3 being the overall outcome that we were looking to estimate. Then we see the estimation information that we're using. These are the default settings, and they're perfectly good for most instances. The chains were allowed to run up to 50,000 iterations, with the first half of the chain being discarded as the burn-in phase. I'll let you know when you need to change the default settings, but for a model this simple, you really wouldn't have to. Then we get the results. And so these are the regression paths that we have listed up here. The initial results are going to be for the posterior estimates, which by default are going to be the median. And results are going to show you which predictors are stronger and sort of pulling more weight of prediction in the model. And so these are unstandardized model results. All the regression paths here, you could map on to a diagram of the model to very easily see which paths were stronger, which were weaker. If the unstandardized results were not in a meaningful metric to you, you can request standardized results and include those instead. But really, it's a pretty simple set of results that is just taking a bunch of regressions and embedding them within a path model.